We are live. So thanks everyone for joining this week's live session with Offset. It's a pretty exciting news today, and you can always hit up Google for that. But today, Sam is going to talk to us about running SpiceDB on your Kubernetes cluster. So he's going to kick that off, and I'll turn it over to Sam, who was one of the founding engineers here at Offset.
Well, thanks, Jess. Hello, everyone. Good morning from my part of the world. I'm based out of Seattle, and it is stereotypically very overcast and gloomy today. So today we'll be covering how to deploy and operate SpiceDB in Kubernetes. And I'm going to kick us off with a few slides. Let me share my screen. All right, so welcome to our talk. So perhaps you saw some of our introductory posts about today's session. One thing we included was this phrase, operating and managing SpiceDB in Kubernetes. And we're trying to make it as convenient and hopefully pleasant as possible. So what do we mean by convenient and pleasant? So I'm going to try, instead of trying to explain that, I will show you. Swap to a different share. Okay.
Oh no, I think we lost Sam for just a second. I'm guessing he swapped screens, and yep, now he's back.
Just trying to share my screen. Okay. Jess, can you see my screen?
I cannot. I see you.
Okay. Looks like I'm having trouble sharing. Let me try one other way of doing that. I'm gonna try this. Okay.
Yes.
With the infinity screens.
That works.
Okay. You see a terminal?
I do, in fact.
Great. So back to being convenient and hopefully pleasant. So here I have an existing Kubernetes cluster running on my machine. For now, you can kind of see this is just a list of currently running SpiceDB pods. I wanted to show that it is, oops. In fact, here's what's running currently, just to kind of give you an example of what's on the cluster. But back to just the SpiceDB ones. So one thing about being convenient and hopefully pleasant is, let's say we wanted to run a new SpiceDB cluster inside of this Kubernetes cluster. So one way we do that is here is a description of a SpiceDB cluster. I'll go into details of what this actually is later in this presentation. But as you can see, it's a CRD. It describes a SpiceDB cluster, a few attributes, some configuration on it. And if we wanted to actually create this and run it inside of our cluster here, we can actually just apply it. We apply it. Back in our cluster, we can see we have yet another SpiceDB cluster that is running. You can see the different states of where it is in the process of being deployed and running. And so currently it's updating. And as it's making progress, oh, and it's running. So that's all it takes to run a new SpiceDB cluster in Kubernetes. Another thing we might want to do is, let's say, as we're running it, we want to update its version. So what we could do that is you can actually go and just edit its definition. You can find its version, and let's say we just wanted to bump it up one version. So edit it, save it. As you can see over here, it found the update. It actually migrated the data store underneath and is currently updating. When that finishes, we'll have a SpiceDB cluster running on version 1.31.0. Another thing you might have noticed is this channel. That is actually, you can actually automate this by setting a channel, and when new releases of SpiceDB are added to the stable channel, this will actually auto upgrade for you. So that's another option as well. So we just created a new SpiceDB cluster, had it running, where it was able to upgrade its version and potentially even automate the updates going forward. So hopefully that's convenient, but also something that is pleasantly surprising. Swap back. Whoop, whoop, whoop. Okay. Let's flip back to our slides. So that obviously is a demo, but those are all real scenarios. And outside of just operating SpiceDB, what else do we need in our deployment to have this running in production? So I'm going to cover those next. To our presentation. So as we go into things to consider, I'm going to do a brief overview of SpiceDB. I'm sure if you're here looking to run SpiceDB in production, you are somewhat familiar with it. But SpiceDB is a database for computing application permissions. Like most databases, you have a schema that, and in SpiceDB's case, the schema represents your particular authorization logic. We write data according to that schema. Those are relationships. And then we make API calls to query that data and to get authorization questions answered. And so the SpiceDB itself was inspired by Google's Zanzibar, and there was a paper published in 2019. That paper actually not only introduced Reebok as a model for authorization, but more importantly, in my opinion, it actually outlines the architecture for making that model perform and scale according to the requirements that Google has. And so if you haven't seen the paper already, we actually host a copy of the paper at that URL, and we actually provide some annotations to help understand the paper. One set of annotations is actually about just understanding the paper on its own, and then we actually provide a second set of annotations that compare and contrast SpiceDB with Zanzibar. And SpiceDB itself is open source. And so that link there is the repo where you can follow the development of SpiceDB. Let's see. So next, again, with SpiceDB, I think there are a few things to consider from going from a development instance to a production instance. Depending on your experience with SpiceDB, for example, if you've been running it in development, you may be running it with an in-memory database, potentially with a single node. And so these are the features to consider before you move that development instance into a production instance. So the first feature to consider is the data store. SpiceDB actually has a data store interface that abstracts the underlying data store, but the specific data store decision is something to consider. There's a number of factors that you want to consider as you move to production. For example, does your application have multi-region requirements? Does your application run in different global regions that potentially need to access the same data store underneath? Do you have an existing preferred cloud provider? Whether it's because of other business requirements or preference, the cloud provider is important to consider. And lastly, does your organization have an existing expertise? You may have built up knowledge around how best to scale an existing database, so that may factor into your choice of SpiceDB data store. So I've listed the officially supported data stores here, and Osted's recommendation for each of them. I'll highlight Cockroach as the data store that is both planet scale ready, has multi-region support, and is available to test with their open source deployments as well. And we actually have a lot of inquiries about Postgres. Postgres is a popular database for application relational database usage. And so many users tend to look to leverage that knowledge and use it for SpiceDB as well. The next SpiceDB feature to consider is caching. And so specifically caching for hotspot mitigation. So hotspots can occur in SpiceDB usage and something you might not see in development without some explicit testing. Hotspots can occur if a particular resource has a spike in accesses or accesses. And the other thing is that difference between a development instance and a production instance may be having multiple SpiceDB nodes. And so each node can have a cache, and as a distributed cache, they store both final and intermediate results. We're not able to go into too much detail, but we'll highlight a couple blog posts. If you go to those two blog posts listed there on our website, osted.com, they go into very low-level detail of how caching works, both in SpiceDB and in Zanzibar. The next feature is dispatch. So dispatch is the concept of being able to subdivide problems and span those subsets of subproblems out to multiple servers. So essentially doing work in parallel. And this is a key feature used by the original Zanzibar paper and SpiceDB to achieve scale. It's a little small, but I added an example permission definition that you would have in a SpiceDB schema. This is all hypothetical and more of just to explain conceptually how problems may be subdivided. But in the example here, we have a permission called member, and member is defined by a union of three relations: a direct member, an administrator, and if they're a member of a group. And so each of those can be computed independently. And so there's an example where if someone checks a permission for member, these three parts of the union could potentially be subdivided and computed independently, and those results can be gathered, and that would be an example of dispatch. And the combination of dispatch and caching is one key concept in Zanzibar. So if a node gets a request, if you combine the ability to dispatch subproblems with consistent hashing, a node could potentially dispatch a subproblem to a node knowing that there may be a cache result on the other node. And so that's where you can get gains in performance. And lastly, it's not a feature necessarily of SpiceDB, but we have extensive documentation around how to load test SpiceDB. And so it's not linked here. Maybe Jess can link to it, but in our documentation, we have a comprehensive guide of factors to consider in your load testing in the process of moving to production. So this was the, I guess, teaser that I did in the demo. We have an open source SpiceDB operator that we use to, that I use to, I guess, show off the convenience of running SpiceDB in the demo. And so the operator is used to manage the installation and the lifecycle of SpiceDB clusters. And it is both designed with cloud native principles and is also designed with Kubernetes native principles. And so the things that we showed in the demo are the creation of new SpiceDB clusters, but behind the scenes, the operator also does a lot of configuration based on the flags that are set for that particular cluster. And so two of the things that the operator configures for you are connections with the underlying data store and dispatch. So with dispatch, having multiple SpiceDB nodes, you need to wire them all up to be able to talk to each other. And so it can be cumbersome if you do it by hand, but the operator handles that all for you. The other part of the operator is that it defines the SpiceDB cluster CRD. That is the YAML that was briefly shown on the screen. That CRD basically lets you both define the versioning on the SpiceDB cluster, but also any flag that SpiceDB supports is also supported by that CRD. And lastly, we have version management. So we saw a simple upgrade of SpiceDB, but another thing that having the operator manage versions for you is that if there are data store migrations associated with version upgrades, it'll handle those migrations with zero downtime. You can also pin versions as well as having the operator auto upgrade for you. And the upgrade graph actually has multiple channels. It defaults to stable, but there are rapid upgrade channels available as well. A few more operator features. There's actually a patches feature as part of a SpiceDB cluster definition. You can actually specify different diffs, and those be applied alongside the SpiceDB cluster. And so where this can be particularly useful is if you have an existing Kubernetes cluster that you want to start deploying SpiceDB to. There may be some intricacies of how particular resources are labeled, for example, and this feature is what you would be able to help fit in SpiceDB clusters into an existing Kubernetes cluster. And like I mentioned, this is open source as well. We think it's the best way to run SpiceDB in Kubernetes, and you can follow along with the progress at the GitHub repo there. And so outside of SpiceDB and the operator, of course, there are other things to consider with a production deployment. I've highlighted a few things here. Each of these has more specific documentation on our doc site. With TLS and Ingress, we use Cert Manager and Envoy heavily. And so there are examples in our examples repo. The data store we covered. We glossed over running those databases themselves, either explicitly as part of your cluster or as part of a cloud provider's offering. But again, we have more documentation on those specifics on our doc site. And with observability tooling, we support OpenTelemetry and the various tools in that ecosystem. And so for metrics, profiling, tracing, SpiceDB has native support for OpenTelemetry, and the details of that are on our doc site as well. And as you are making progress, if you need help, we have a robust community with a community provides support in our Discord channel, our Discord server. And if you find that you have more time-sensitive needs or would like to ask more specific questions of the outside team, we have support packages available as well, and we'll be able to do live one-on-one sessions if that would be helpful. And that concludes the presentation portion. We do have some time for live Q&A. So if there's any pressing questions, please add to the chat and we'll get to them.
I have a question.
Yep.
So if I run into trouble, like, is there a particular place in Discord or on GitHub that I should ask questions? What's the best avenue for me to seek help?
Yeah, so on GitHub, we do have a discussion board. You can file issues or ask specific questions in there. That'll be probably the most async way to do it. With Discord, the benefit is that there are people around pretty much around the clock, not guaranteeing response times, but if you want more synchronous communication, Discord is probably your best bet. And more often than not, you'll probably encounter an outside engineer in there.
Very likely. I have another question, maybe while folks are typing. Do I have to deploy SpiceDB via Kubernetes, or can I use other orchestrator tooling? What are my other options?
Good question. You do not have to use Kubernetes. We just at Offset have extensive Kubernetes experience, and so we've built up tooling to make running SpiceDB in Kubernetes as easy, convenient, pleasant as possible. But you can run it. You can run it as a container anywhere you prefer. A lot of times, especially in development environments, people use Docker Compose. We even have examples, again, in our examples repo, where there's a simple Docker Compose file that you can use to get a simple SpiceDB stack up and running. Those are better suited for development or testing environments, but we know of clusters that people have kind of spun up semi-manually, unfortunately, in their preferred environments.
Cool.
Let's see.
I do see someone typing still, so maybe I think one thing that's pretty interesting is like the robustness of the SpiceDB operator, particularly given that a lot of folks on the team had a pretty big hand in helping to develop like how operators even work originally.
That's a good point. Yeah, the developers of the SpiceDB operator actually were a lot of the developers of some of the frameworks used to design and develop the original operators at Red Hat. So I think that experience is reflected in the elegance of the SpiceDB operator.
Yeah, I do see a good bit of feedback about that, and I didn't know that when I started, so it was a very pleasant surprise for sure.
Related shout out, we actually have another open source repo called the Controller ADMs repo. That is an open source framework for developing operators. That is an offshoot of the work done for the SpiceDB operator. And so it makes building Kubernetes operators more elegant.
One question, are there any plans to open source Thumper for load testing?
We have looked into different avenues of providing load testing help, both through tooling and through guides. We're still working on the best way to do that, and whatever we arrive at, the plan is to open source them. So whether that's Thumper or a new tool, that's something that we're actively working on.
And maybe just for the others in the chat, could you explain what Thumper does, like very briefly?
Yeah, so Thumper is a load generation tool specific for SpiceDB. The input to Thumper is a set of scenarios that represent a shape of API traffic. And so, for example, you can say, I want check permission requests at this request per second, look up subjects at this request per second, with specific requests, I guess, with specific request data. And so the combination of those scenarios plus the data that you store in your test SpiceDB, you can actually model what more closely, more real world related traffic to SpiceDB. So it's a good way both to load test before you go into production, but it's also a good way to have a canary for running production instances.
And I am dropping a link here to a blog post where we where we talk about how we generated the data for load testing SpiceDB and getting to 1 million QPS. That was a pretty cool in-depth review of how we actually measure that workload. Excellent. We'll do one final call. If I see anybody start typing, we'll stick around for a little bit. But otherwise, I think we'll end this session. So going once, going twice. I think we're good. Thank you so much, Sam, for presenting and sharing your experience with us. If anybody has any other questions, just like Sam said, feel free to pop in Discord. Sam and I are just Sam and Jess in there if you want to talk to somebody specific instead of going into the group chat. Feel free to reach out to either of us. And we'll see you next time.
Thanks.
All right, thanks.